Welcome to today's Ag webinar. Today we have Elle Fordyce, a Beef Extension Officer from Department of Primary Industries in Katherine, and she's going to give us a rundown on some of the research and projects that they're working on in the Katherine region.
I'm the Beef Extension Officer in Katherine. I'm working in the livestock industry, and I've been in this role for about 3 to 4 months now, but I've been up here for about 9 months. So we've got a variety of research projects going on across different departments, but today I'm just going to be focusing on 5 that are going on in the livestock industry area. And these are the calf watch, the cool calves, the Repronomics 2, the phosphorus supplementation, and the pain relief trial. So just as Chelsea said, if you guys have any questions, just stick them in the chat, and I'll do my best to answer them at the end of the presentation. So the first one is Calf Watch. That's headed up by Tim Schatz. It is based on Mambaloo Station, which is just outside of Katherine, and we lease 2 paddocks on that. So Tim, Kieran, Mel, and myself, we're based between Darwin and Katherine, and Rael is based with the University of Florida in the USA. So that's the main people sort of involved with this project. The death of calves in the first 2 weeks of life conservatively costs the northern beef industry $54 million annually. So this is not including past that 2 weeks of age if we lose any calves after that. So it is a massive impact on the northern beef industry. As you can see on this map, it details the loss on different properties in the region. So up here, we're doing 15, 24, 12. We also have these higher numbers of 34 and 32, 39 down in between Katherine and Tennant. So it is getting quite high, and is why we needed to really address this problem. In previous research, the main issue has been finding the deceased calf on time, so we're able to conduct a post-mortem on the animal and really determine the specific cause of death so that we can address that and hopefully change it and increase our survival rates. They're large paddocks, they're dense vegetation, and so it really hasn't been viable to conduct this sort of research before. So the aim of the Calf Watch project was to develop a method to remotely monitor calving, find the deceased calves in a timely manner, and determine the cause to reduce calf loss. So this was a collaboration with the University of Florida. They have birth sensors that we used, but the difference being in that Florida, they're big grassy open paddocks. As in Katherine, as you can see down the bottom here, we've got a lot of grass, we've got a lot of vegetation, and it's much more difficult to find. So with that, these sensors were inserted in about August, and we were calving from October to December. They are inserted similar to what a cedar is, and then once a birthing event starts, they are actually expelled. And when they're expelled, the change in temperature, that triggers them to go into a beacon mode. So they start sending signals via these big towers, and they get emailed to us so we know a cow is having a calf. In conjunction with that, to make them a bit easier to find, we were actually using GPS transmitting collars. So when we got an alert that these birth sensors were expelled, we'd jump online, check out where the cow was at that specific time, and we could locate her in the paddock. She usually isn't too far away if we get on top of the alert. And we'd go out and check on her and her calf, and we'd monitor them for the next 2 weeks. So in a case that we'd find a dead calf, we were able to find it early on enough that we were able to bring it back for post-mortem and get some ID on actually what is causing the death. This map here is a collaboration, I guess, between Smart Paddock and Cow Monitor, which were the 2 websites we used to receive the GPS and the sensor information. So we were able to pinpoint the location of where calves were born and found. So the sensor locations, they are these little green dots. These 4 towers that covered the GPS area, they're the yellow ones here. And then our main watering point was up in this corner as well. And it was interesting to note that these are our heifers as well, these red dots, and they just tended to calve a little bit closer to that water point, and with other cattle as well, is what we sort of noticed out there in the paddock. We got some really interesting results from this. We identified that bottle teats were a much bigger issue than we first thought. I was out in the paddock and we were seeing really neat udders up until about the day before they would calve. The day before they would calve, these teats would just blow out. The calf would be born, it would struggle to suckle, and then over the next couple of days, it would just go down in sort of weakness and all this sort of stuff. So we'd pull them off for welfare issues. But then the main takeaway from that was that they would then go back to being quite neat udders, and definitely wouldn't be identified as having bottle teats at a muster. So that might be a potential cause of calf death that we saw. So in this graph here, you can see it's 6% on the bottle teats. We had 1% dystocia loss. I think that may have been in heifers. We also had 2 unknown causes of death. And then we had 0.6% of neonatal septicemia, and 0.6% of an infection of umbilical cord. So all in all, about 17% calf loss. This year, actually, we have improved on the GPS collars. So we had a couple of issues with them last year falling off. And we also had a heat wave come through and knock a couple out because of the extreme conditions. So they have all been accounted for, and we're running new collars this year. And hopefully with that, we're able to find a couple of more calves a bit more accurately. So that will be interesting to see how this year goes. The second project I want to talk about is Cool Calves. So Kieran McCosker is the project leader on this. He's working with a number of people and with Avon Downs to have a look at what the effects of exposure are on calf loss. There's going to be some more information about this coming out on Future Beef in the upcoming days as well, so watch out for that. Kieran was down at Avon Downs a couple of months ago just to keep this project moving. But calf loss, as I've said in the previous slides, is a major economic cost in the beef cattle herds of Northern Australia. Particularly on the Barkly, they are breeding on treeless rangelands. So we're having a lot of sun exposure, especially if we're calving between that October-December time. So this is a collaboration between the NTDPIR and Avon Downs, funded by MLA. And the aim is to investigate the effectiveness of providing shade in a treeless rangelands at the reducing occurrence of fetal and calf loss in maiden heifers. So this project started last year around July. It's proposed to be finished in 2023, but that date is still to be decided on. So 151 pregnant heifers were randomly allocated to Grant's paddock. That Grant's paddock had a shade structure in close proximity to the water point. So as you can see in these photos, this is a close-up of that shade structure, and you can see the proximity to the water point from this second picture down here. The second paddock, Lux paddock, they didn't have any shade structures. It was mostly treeless plains. There was some native vegetation that provided minimal shade, but nothing like this shade structure that we have here. So they were stocked with 75 purebred Wagyu heifers and 4 bulls in Grant's paddock, and 76 purebred Wagyu heifers and 3 bulls in Lux paddock. These cattle were fitted with GPS collars to track the location and the temperature, so we could determine whether they're spending more time in the shade, if it's provided or not, and just to monitor their temperatures as well. The results that we got from this weren't drastically significant. There is a little bit of difference between shade and non-shade, but overall it was not significant. It is a small pilot group, and we will be accounting for natural shade in the ongoing trial. So we'd expect to see some bigger differences in these upcoming years. These new collars have just been deployed, so they're going to be assessing natural shade in conjunction with satellite imagery. So hopefully we'll get a little bit better understanding about whether they're utilizing the minimal vegetation that they have on these rangelands. But of particular interest, we're going to be looking at the calf loss comparisons, um, looking at the difference between shaded and non-shaded paddock. So as you can see here, we've got losses between confirmed pregnancy and weaning. There is a slight difference, but we're hoping to see that a bit better in the upcoming years of this trial. The third project is Repronomics 2. So that's being headed up by Tim Schatz with the assistance of Whitney Dollamore, Gretel Bailey Preston, and all of the staff on the Douglas Daly Research Farm and the Victoria River Research Farm. Repronomics 1 has officially ended, and Repronomics 2 has started well and truly. The genomic selection, it is a powerful tool in the livestock breeding, but it does have little application due to the low numbers genotyped, as it can be quite an expensive activity. So collaboratively with AGBU, Australian Genetics and Breeding Unit, and the Queensland Department of Agriculture and Fisheries, we're putting together the Repronomics 2, which is going to run for another 5 years in succession of Repronomics 1, in the NT that's located at the Douglas Daly Research Farm. So this year we've actually expanded to using our tropical composites as well as Brahmins to get that across breed genotyping. So that will be really great for the project, adding around another 2,000 animals to our reference group. So the objectives of Repronomics 1 was to genotype industry sires to build the foundation for trait recording for female reproduction, collect a large quantity and quality phenotypic data of female reproduction traits, and to use the sire and female genotyping to validate and enhance the genomic selection for female reproduction in tropical breeds. So these were all deemed achieved in the final report for Repronomics 1. And so moving forward into Repronomics 2, they're looking to improve the accuracy for estimated breeding values for fertility in the tropically adapted breeds. So this is going to be able to give the producers the ability to make breeding selections based on production goals, and compare them across compare breeds, on EBV. So we're going to be able to compare, different sort of breeds instead of Brahmins to Brahmins. So that will be pretty fundamental in what the Repronomics is wanting to achieve in Repro 2. So here, the sire and dam selection is going to be able to be based on production goals of individual properties. Your comparisons are, as I said, are going to be able to be made across the breed. So with Repro 2, every 6 weeks, the yearling heifers' ovaries are scanned until they start cycling. So they either become pregnant or a CL is detected on the ovary. That way we get their date of puberty or their month of puberty. Heifers that have had their first calf, they're scanned again from the end of mating until they resume their cycling to identify the anestrus period. So that is another really important female reproductive trait that we're trying to genotype for. Moving on to our fourth project is Kidman Springs Phosphorus trial. It has been out and about a lot lately. Tim has been presenting a couple of webinars for that. So I'm sure some of you will have heard of it already. It was a pretty successful trial with some confronting results, I guess, but very much needed for the industry. Approximately 20% of the land in Northern Australia would actually provide cattle with a diet that is adequate in P. So it is quite low. The sales of P supplementation in the NT don't represent the amount of deficient country. And prior to this, there was little information about the cost effectiveness of supplementing breeding females. And so we're getting uninformed decision making, which was contributing to the production or productivity of running stations. So that led to the Kidman Springs Phosphorus Supplementation Project. P is obviously extremely important in all body bodily processes. But the major impact of phosphorus deficiency in cattle is a huge reduction in appetite. So when you've got that low pasture intake and consequently the lower energy and protein intake, you get poor nutrition. They're not able to maintain their body condition. You get lower weaning rates, you get increased mortality, and all of these have a really significant impact on production and profitability. So in the first year, 179 Brahman weaners, heifers were randomly allocated into a phosphorus positive or phosphorus negative treatment. They were mated at 2 years for 4 months from January 2016, and this continued for 5 years. So they were mustered twice a year for data. Their blood sample was collected to get that inorganic phosphorus content, and then we had our regular weaning processes. In the next slide, I'll show some results, but we had huge differences in pregnancy rates between the P plus and P minus treatments, and some really massive differences in mortality rates as well. So P supplementation is quite literally life or death for some cattle. As you can see here, these guys were P supplemented and are looking very healthy. And these ones are not looking quite as healthy. We did have to remove a couple for welfare because they were just in such poor condition. So phosphorus is quite important. The economic analysis, it showed that at a commercial property scale, the P supplementation in deficient country can actually deliver one of the best returns on investment available. Tim has more of the economics behind of that. So he would be great to have a chat to if you're interested in this sort of stuff. But as you can see, the average weight is over 100 kilos difference between the P plus and P minus. We had a 9% pregnancy rate compared to a 75% pregnancy rate in the two groups, and then 28% mortality rate in the P minus compared to 1% in the P plus. So they are really staggering results, but demonstrated the absolute necessity for providing P supplement to cattle. That was a very good one. So to finish up on my last update is the pain relief trial. So Melissa Wooderson is actually putting this together, pardon me, and it has been running on our research stations for the last year, but she's going to be continuing this after COVID sometime ends, we hope. But basically, pain relief is becoming more and more questioned and more common practice, especially up in larger production systems in Australia, in Northern Australia. And so the DPIR is conducting this trial funded by MLA, where we're examining the production and welfare benefits of managing the pain during routine husbandry procedures. So this is dehorning and castrating mainly. So Mel is using trisulfan and meloxicam as the two forms of pain relief in her trial. It's a pretty simple trial layout, but I'm sure it'll provide some pretty interesting information. They're separated into 4 groups when they come through. The trisulfan group, so they only get the trisulfan, which is the topical anesthetic with antiseptic properties. They get the meloxicam. So the meloxicam actually is an injectable. And then number 3 treatment group gets the trisulfan plus the meloxicam. And the 4 is just the current industry practice, so no pain relief while conducting these procedures. They're all released in a holding pen, and we have 4 GoPros that are set up to monitor their behavior. So we're looking for ear flicking, whether they're tossing their head, whether they're marching around or just being quite calm, sitting down, that sort of activity. The GoPros are set up on each sort of side of the pen, so we can get a 4-angle view of the pen to be able to ID animals and watch them for a specific amount of time to record activities. We're looking into getting accelerometer collars as well. So they're just to record behaviors and get more specific information on, say, head flicks or ear flicks, and marching and all of that sort of stuff. So the cattle are then brought in about 3 weeks later. You re-examine the wounds, you re-weigh them, and that's what we're using to determine their production cost if we're losing production in not using pain relief. This trial is actually still needing participants. So if you're interested, you need about 600 calves that need to be castrated and or dehorned. This can be at your usual mustering time. No changes needed to be made there. They do need to be tagged and weighed prior to the procedure so that we can monitor what they're doing in the yards and also monitor their weight change when they come back in. The DPIR is going to provide the pain relief products, and most likely Mel or someone else from the livestock team is going to be down there to help you guys record the data. But one hindrance, or something that most larger production systems don't tend to do, is reweighing the calves 3 weeks later for comparison of the 4 treatment groups. So that's something has to be done. If you would like more information on that, Mel is the person you need to contact. Her details are there. But yeah, that is a quick update on 5 of our projects running. There's a lot more projects going on at the moment. And yeah, if you'd like any more information, I'd be happy to answer your questions.